ওকে স্টুডেন্টস, আজকে আমরা ক্লাস 9 এর ফিজিক্সের সেকেন্ড টপিক নিয়ে আমাদের ডিসকাশন স্টার্ট করব। আমাদের সেকেন্ড টপিকটা হচ্ছে ফোর্স অ্যান্ড লস অফ মোশন। এই ফোর্স অ্যান্ড লস অফ মোশন বুঝতে হলে প্রথমে আমাদের বুঝতে হবে ফোর্স কি করতে পারে। What are the different types of force that are present along with us? Firstly, try to understand what do you mean by force. Force is a physical quantity. It's a cause that can change the state of rest or of motion of a body. It can change the direction of a moving body. It can change the shape and size of a body. তাহলে কি করতে পারে? একটা বডি যেটা রেস্টে আছে সেটাকে মোশনে নিয়ে যেতে পারে, একটা বডি যেটা মোশনে আছে সেটাকে রেস্টে নিয়ে আসতে পারে, একটা বডি যেটা মোশনে আছে তার ডিরেকশন চেঞ্জ করতে পারে, অন্যদিকে একটা বডির শেপ এবং সাইজ কিন্তু চেঞ্জ করতে পারে এই ফোর্স। তাহলে ফোর্স ইজ অ্যাকচুয়ালি আ কজ which can do these things. Okay? Now this force is of two types. One is called the contact force. Next is called the non-contact force. One is the contact force, another is the non-contact force. Now what do you mean by contact force? যেই ফোর্স গুলো শুধুমাত্র তখনই অ্যাক্ট করতে পারে যখন দুটো অবজেক্ট আর ইন physical contact. So what happens? So if they are in physical contact, what happens is this force actually acts. And if such forces are present which can act even from a distance, যেগুলো ডিসটেন্স থেকেই অ্যাক্ট করতে পারে, সেগুলোকে আমরা ক্যাটাগরাইজ করছি অ্যাজ নন-কন্ট্যাক্ট ফোর্সেস। কন্ট্যাক্ট ফোর্সের একটা এক্সাম্পল, কন্ট্যাক্ট ফোর্সের এক্সাম্পল হচ্ছে অ্যাকশন রিঅ্যাকশন ফোর্স। কন্ট্যাক্ট ফোর্সের একটা example হচ্ছে action reaction force, not always action reaction force, rather I will write normal reaction force. Normal reaction force এর কি example? আজকে আমি এই পেনটাকে আমার হাতে রেখেছি, এই পেনটা নিচের দিকে একটা ফোর্স অ্যাপ্লাই করছে আর আমার হাতটা এই পেনের উপর একটা ফোর্স অ্যাপ্লাই করছে। So there is an action force, there is a normal reaction force. এটা তখনই পসিবল যখন there is a physical contact between this pen and my hand. Therefore, this is a contact force. On the other hand, if you see about this non-contact force, try to understand. There is force like gravitational force. Gravitational force. There is force like the magnetic force. There is force like electrostatic force. এগুলো কিসের এক্সাম্পল? এগুলো হচ্ছে এক্সাম্পল অফ নন কন্ট্যাক্ট ফোর্স। গ্র্যাভিটেশনাল ফোর্স মানে কি? It is a force which is acting between two bodies. দুটো বডি রয়েছে, দুটো বডি ডিসটেন্সে রয়েছে। তোমরা পড়েছো আর্থ আর সানের মধ্যে রয়েছে, তাহলে আর্থ আর সান কি ফিজিক্যাল কন্ট্যাক্টে রয়েছে? না, আর্থ আর সান ফিজিক্যাল কন্ট্যাক্টে নেই, তাও তাদের মধ্যে কি হচ্ছে? তাদের মধ্যে এই ফোর্সটা অ্যাক্ট করছে, হোয়াট উই আর কলিং অ্যাজ গ্র্যাভিটেশনাল ফোর্স। ম্যাগনেটিক ফোর্স, ম্যাগনেটিক ফোর্স কি হচ্ছে? তোমরা পড়েছো যে ম্যাগনেটের মধ্যে অপোজিট পোলস অ্যাট্রাক্ট ইচ আদার, সিমিলার পোলস রিপেল ইচ আদার। দ্যাট হ্যাপেন্স also from a distance. So this is actually a non-contact force. Electrostatic force, opposite charges attract each other, similar charges actually repel each other. That is also acting from a distance. So all these are non-contact force. তাহলে বোঝা গেল ফোর্স দুটো টাইপের হয়, একটা হচ্ছে কন্ট্যাক্ট ফোর্স, একটা হচ্ছে নন কন্ট্যাক্ট ফোর্স। কন্ট্যাক্ট ফোর্স তখনই বলবো যদি ফোর্সটা শুধুমাত্র তখনই অ্যাক্ট করে when the two bodies are in physical contact. And if the bodies are acting a force upon themselves even from a distance, যদি ডিসটেন্স থেকেও একটা ফোর্স ওদের মধ্যে অ্যাক্ট করে, তখন আমরা কি বলবো? দ্যাট ইজ কল্ড আ নন কন্ট্যাক্ট ফোর্স। নন কন্ট্যাক্ট ফোর্সের মধ্যে আমরা তিনটে টাইপ কি দেখলাম? গ্র্যাভিটেশনাল, ম্যাগনেটিক, and even we found that this is electrostatic force. Now এই নন কন্ট্যাক্ট ফোর্স গুলোর দুটো ক্যারেক্টারিস্টিক রয়েছে, ভেরি জেনারেল ক্যারেক্টারিস্টিক্স রয়েছে। কি সেই ক্যারেক্টারিস্টিক্স? প্রথম ক্যারেক্টারিস্টিক হচ্ছে, see here, these forces can be either attractive or repulsive. আবার বলছি, these forces can be either attractive or repulsive. যদি আমরা এখান থেকে এক্সাম্পল তিনটাকে নিই, তাহলে electrostatic force and magnetic force, they can be either attractive or repulsive. But gravitational force is exceptional. Gravitational force is always attractive in nature. Is it clear? Similar charges or similar poles are repelling each other. Opposite poles or opposite charges are attracting each other, as in the case for electrostatic and magnetic force. But when we are talking about gravitational force, there are two bodies who are only attracting each other. There is no case of repulsion in case of gravitational force. So the first point is these forces can be either attractive or repulsive in nature. The second point that I will discuss is very important. The second point is that these forces follow the inverse square law. What do you mean by inverse square law? Actually, these forces are directly proportional, not directly proportional, rather inversely proportional to the square of the distance. Means, if you increase the distance, what will happen? These forces will decrease. For example, I am giving you a case, gravitational force. That is capital G into M1 into M2 divided by R square. Okay. So if the distance between both of them is increased, if it becomes 2R, so this becomes 2R square. So the force becomes reduced by, the new force will be F by 4. So if you increase the distance twice, the force is reduced by 4 times. If you increase the distance thrice, the force is reduced by 9 times. If you increase the distance by 4 times, the force will be reduced by 16 times. So this is the basic thing that we have to understand. Is it clear? This is the thing which we have to understand regarding contact and non-contact force. Now we are coming to the main discussion, that is called the laws of motion. Now let us understand what do you mean by laws of motion. All these laws of motion were given by Newton. Newton has given us 3 laws of motion. And all these 3 laws of motion are very important from the perspective of physics. Almost half of the physics can be done by this. The entire mechanics is dependent on this. Let us understand these laws of motion. Today we will discuss only the first law of motion. What is the statement of the first law of motion? This first law of motion states that an object in the state of rest will remain in the state of rest, and an object in the state of motion will continue its uniform motion unless an external force is applied on it. Let us understand this statement. An object which is at rest, that will remain at rest. An object is in motion, that will remain in motion, and that also uniform motion, means its direction and velocity will remain fixed unless an force is applied. Is it clear? So if we apply force, we can convert rest to motion. If we apply force, we can convert motion to rest. These are the things which we have to understand. If we are applying force, we can convert a body at rest to a body at motion. Okay. If we are applying force, we are converting a body at motion to body at rest. Okay. We are applying force. We are driving a car. We are accelerating a car. So the car initially was at rest, now starts to move. We are applying brake to the car. We are applying force. So the car which was moving now comes at rest. So force is needed to change the state of rest or of uniform motion of a body. This is what is said in this law. But the question is the law so simple? No, it is not. Actually, it is not that simple. Okay, fine. If we apply force, an object in the rest can come to motion. If we apply force, an object in the motion can come to rest. But the question is it always true that if we apply force, a body at rest will come to motion? Is it always true that if we apply force, a body at motion will come to rest? It is not true. Because try to understand this thing. Suppose you are pushing a wall. You are pushing a lorry. What is happening? You alone are pushing a lorry. What is happening? You are applying force, but the lorry is not moving. So the object was at rest. Even after applying force, it is at rest. Is it clear? So now can you understand? If we always apply force, that doesn't mean the object's state of rest will change to its state of motion. This is not always true. Then the question comes, how can we justify that? I am giving you an example. If you are given a 5 kg sack of rice and you are asked to take it from here and keep it there, you can easily keep it. But if you are given a 500 kg sack of rice and you are asked to take it from here and keep it there, you are unable to do it. Why? You are unable to do it. Why? The answer is because your force is not sufficient enough to move the body. This question brings us to a concept of inertia. What is inertia? This is what you write. Inertia, I-N-E-R-T-I-A, this concept. So Newton's first law of motion brings us to the concept of inertia. What do you mean by the concept of inertia? Inertia is an inherent property of an object by virtue of which it tries to resist any kind of state of change of rest, change in the state of rest or of motion. What is meant by that? If the body is at rest and if we are applying force to bring the body in motion, the body will try to resist it. If the body is in motion and if we are applying force to bring the body at rest, the body will try to resist it. This resisting property that no, I will remain at the state what I am in actually, that is called inertia. Now the question comes, on what factor does inertia depends? The answer is inertia depends on mass. Why? How? The answer is very simple. I have just given you an example of the 5 kg sack of rice and a 500 kg sack of rice. You have seen the difference between the two is actually the mass. When the mass is increased, it is difficult for you to bring that sack of rice from one place to another. So it is the mass which is the measure of inertia. Often in your exam you will find the question, mass is the measure of inertia. How? Mass is the measure of inertia because on increasing mass, the resisting property of the body to remain in its state of rest or of uniform motion increases. Hence, mass is the measure of inertia. Is it clear? Now this inertia itself is actually of two types. One is called inertia at rest, inertia of rest, and another is called inertia of motion, inertia of motion, inertia of rest and inertia of motion. What is meant by this inertia of rest and inertia of motion? Inertia of rest means the body was initially at rest. We are applying force to bring the body in motion. But even after that, the body is remaining at rest. This is called inertia of rest. What is meant by inertia of motion? The body was initially at motion. We are applying force to bring the body at rest. But the body still tries to be in the state of motion. That is called inertia of motion. So whenever I am telling inertia of rest means originally the body was at rest. If we are talking about inertia of motion, originally the body was in the state of motion. That's the consideration that you have to understand. No one will ask you what do you mean by inertia of rest or inertia of motion. That's not going to come in your exam. But what will come is some explanation on the basis of these inertia of rest or inertia of motion. One more thing, we will come to this inertia of rest or inertia of motion. But one more thing which is important in the case of this first law. In the statement of the first law, it was said that unless an external force is applied on it. So the term force was there. This first law actually gives us the qualitative definition of force apart from the concept of inertia. So we get two things from the first law itself. The first is the inertia. The second one is the concept of force. That is concept of inertia, that's the first one. And the second one is the definition of force. When we will discuss the second law of motion and third law of motion, what we will understand overall is that there are two such definitions of force. Why two definitions of force? The reason is, one is the qualitative definition, another is the quantitative definition. Now you will start thinking that what do you mean by qualitative definition and what is quantitative definition? Qualitative means if I tell you about the quality of a person, that doesn't actually give you a mathematical expression to find out what quality, how the quality is getting affected. That is called qualitative. If I tell you that Ram is a good boy or someone else is a good boy, so that doesn't mean that how good he is. You can't measure that. To me he is good, to you he is bad, and so on. Or maybe you cannot measure actually how good he is. For that you require a parameter. To measure something you require a mathematical expression. If you get some mathematical expression from a definition, then that one becomes an qualitative, not qualitative, but quantitative definition. Okay, qualitative definition will tell you that what it is, what it can do, by how much it can do, and how can you measure it. That you will get it from quantitative definition. So we will get qualitative definition of force. And what is the definition of force? Qualitative definition of force that we get from Newton's first law of motion. It is, force is that cause which can change the state of rest or of motion of a body, or it can change the direction of motion of a body. Is it clear? So this is what we have to remember from Newton's first law of motion. The next part which we were discussing previously, inertia of rest and inertia of motion. What is inertia of rest? What is inertia of motion? We have discussed. Now I am giving you an example of inertia of rest. When a burst starts suddenly, the passengers tend to move backward. Why? When a burst starts suddenly, the passengers tend to move backward. Why? Because initially both the upper and the lower part of the passenger's body were at rest. As soon as the bar starts off, what happens? The lower part of the passenger's body, which is in direct contact, what happens? It moves forward. So the upper part of the body, due to inertia of rest, moves backward. Okay, it remains at rest and it feels that the person is falling backward. Another example I am giving you. This one is for inertia of motion. As soon as the brakes are applied, suddenly the passengers tend to fall forward. Why? This is because when the car was moving, both the passenger as well as the car was in motion. As soon as the brakes are applied, the lower part of the passenger's body, which is in direct contact with the bus, immediately comes to rest. But the upper part of the body, due to inertia of motion, continue to be in motion. So it tends to fall forward. One more example I am giving you. This one again for inertia of rest. This one is for inertia of rest. What happens? How can you remove the dust from a carpet? You hang the carpet, you beat it with a stick. How is that possible? This is because what happens is when you hang the carpet and beat it with a stick, initially both the dust as well as the carpet were at rest before beating it with a stick. As soon as you beat it with a stick, what happens? The carpet moves backward, but the dust particles, due to inertia of rest, remains at rest and then falls down due to gravity. Is it clear? Next, coming to this one, that is inertia of motion. When you get off from a moving bus or train, you need to walk a certain distance. You have to run a certain distance or jog a certain distance before coming to rest. Otherwise, you may fall down. Why? This is because if you jump off from a train, a moving train or a moving bus, what happens is, actually, as soon as you fall on the ground, what happens is the lower part of your body immediately comes to rest. But the upper part of the body, due to inertia of motion, remains at motion and it tends to fall forward. So this is the second point. Third point I am giving you, that is, if you have a glass over which you have kept a card, and over that you have kept a coin. Now if you swiftly move the card away, what happens? The coin falls on the glass. Why this happens? This happens because initially the card and the coin were at rest. If you swiftly move away the card, what happens? The coin, due to inertia of rest, remains at rest, and then due to gravity it falls down. One more example of inertia of rest. You have a pile of coins in carom. You strike it with a striker, the bottommost coin actually gets removed. All the other falls down and it remains as it is. Just the bottommost coin is removed. Why? Because the others, due to inertia of rest, remains at rest. The others, due to inertia of rest, remains at rest. Only the bottommost coin is removed. The others, due to inertia of rest, remains at rest and they fall down due to gravity. This is the basic concept that we understand from this Newton's first law of motion. Now what we will discuss more is that we will, in the subsequent classes, obviously, we will discuss about the second law, we will discuss about the third law. This will take 2 more classes. For the second law, for the third law. Second law is very, very important. Third law is also very important. We will discuss about some points regarding that. And you have a part of gravitation. So this will take 4 or 5 classes to get completed about this topic. Or even it may take more because we have to practice numericals. So I am telling you what will be the schedule. Next class is Newton's second law. Then we will discuss about third law. Then we will practice sums or numericals on the basis of that. Then we will move on to the next class, which is about gravitation, and then some numericals regarding the gravitation. Also, it will take 5 or 6 videos to get completed. Okay. So thank you very much. You keep on watching my videos, and what you have to do is, at home you have to practice this sum. Practice these chapters, all the previous chapters sum, as well as the topics which we have discussed. তাহলে আজকে এই অবধি তোমরা বাড়িতে পড়াশোনা করতে থাকো আর আগের চ্যাপ্টারের কিন্তু সামগুলো ভালো করে প্র্যাকটিস করতে থাকো। থ্যাংক ইউ। বাই।